Hi everyone, I'm David from ProWarm Underfloor Heating. We're on site today in a new build. We're going to be installing a multiple zone system. We're going to be showcasing two of our most popular installation methods. So we're going to be using our clip rail system, and we're going to be using our pipe staple system. The pipe that we're going to be fitting today is per al per, and it's all going to lead back to this manifold. Here you can see we've got an example of one of our bespoke CAD designs that we've created for this project. We've got a total of 5 thermostatic zones, so 1, 2, 3, 4, 5. Those zones are comprised of 9 circuits, each colour denoting a different coil of pipe. These little yellow tags indicate the lengths of the circuits, and what we're trying to achieve is each circuit less than 100 metres in length. Reason for that is it reduces the workload on the pump and facilitates a more even distribution of heat across each area that the circuit covers. You can also see that it's laid out in a serpentine counterflow pattern. This again is to reduce the presence of cold spots and ensure we get a nice even heat distribution across the floor. As I said at the start of the video, we're going to be showcasing 2 different installation methods today. So we've got a clip rail that we're going to showcase in this room here, and all of this lot will be done using our pipe staples. And you can see it all connects back to the manifold, which we did briefly talk about, but again we'll cover in more detail as the video progresses. We're going to be starting from the room that's the furthest away from our manifold. As I said before, this room is going to be showing off our clip rail system. I've got a couple of the clip rails just by my side here. So as you can see, the clip rails are 1 metre in length. They have a self-adhesive backing, which you just peel this and stick it down. They also have a few holes every so often where you can drive in a pipe staple to help secure the clip rail down, just for additional security. As you can see, we've got the grid membrane already fitted. We've got the edge insulation up against our perimeter walls. We've stapled that down as well, as we're going to be having a liquid screed and we don't want anything coming underneath there or getting to the insulation below and lifting it up. We're going to be positioning our first clip rail along this line. This is roughly 300 mil away from the wall. The reason for that is it's a nice clear line to follow on the grid membrane, and it's also going to give us enough space so that once the clip rail is installed, we can get the bends on the pipework. So the actual clip rails themselves will interlock. Now it's going to peel the back in, get these fitted. You want to ensure that your clip rails stay parallel and straight, as your pipe will follow this pattern, and you want to position the clip rail at roughly 600 to 700 mil intervals. So as you can see, we've got our pipe loaded onto our decoiler. We've got quite a narrow hallway that we've got to come down to get our pipe back to where we're going in the snug, where we've just installed the clip rail. There's going to be a lot of pipe running through this hallway, so to avoid overheating, we're going to sleeve up the first 10 metres with this pipe conduit. So we're using a per al per pipe. The reason we're using the per al per is because the al stands for aluminium. This gives the pipe a rigid inner core, which is a reliable oxygen barrier, and once you bend it, it retains its shape. If you use a pipe that doesn't have the aluminium core, you bend it, and it just springs back. So we've now completed the installation in the snug using the clip rail. We're now moving on to the bedroom and the bathroom. We're going to be using the staple system for this and for the rest of the project. For that, we've got one of these 40mm clips here. These come collated, and the reason for this is so that they can be loaded into staple gun. So they sit on this little rail here, and this will save you a lot of labour, because as you can see, we've got a lot of pipe to go down. Literally hundreds of staples will be going into this floor. You don't want to be putting them in one by one. Ideally, you would use a staple gun. So this room that we're in right now is going to be a bedroom. If you follow me through to this section here, this is going to be the ensuite. As you can see, we've marked the position of where the bath's going to go, and we've also marked on the floor with this bit of duct tape where the vanity unit's going to go. The toilet is going to sit on this wall, but it's wall hung, so we don't need to worry about that. But it's very important that you avoid these fixtures, as when other trades come in later on and are fixing these into position, they could accidentally drive a fixing through the pipework. So it's very important not to put your pipe underneath these things. We've finished laying our pipe work now. We're going to start making off the connections to the manifold. As you can see, we've connected all but one circuit, obviously this one. So we're going to just demonstrate now how you would go about cutting the pipe and then making the connection to the manifold. First of all, you take your pipe cutters, and push the pipe down, And then you want to cut it just about there. We're next going to take our re-rounding tool. We're using a 16mm pipe, so we're going to use the 16mm fitting on the re-rounding tool. Just that in there. This puts a nice chamfered edge onto the pipe, ready to receive our fitting. So Eurocone fitting comes in 3 components. First of all, you've got your nut, which goes on first. Split olive. And then the insert, which essentially is an adapter to 16mm to 3/4 for the thread on the manifold. You take spanner, just going to hand tighten first. And once you can't go anymore, so you get your spanner on there, I'm going to just tighten up the rest of the way. Once we've got all of the pipe connected, you might notice we've got some writing on the pipework. This is obviously deliberate, so we know that which circuits correspond to which of the zones on the system. So this one is labelled as the study. So this is important because later on, when we come to do the wiring and fit the wiring centre, we'll need to know which of these actuators that we would fit to the bottom row of the manifold correspond to which zones. So essentially these are just like a motorised valve that correspond to the thermostats. So when the thermostat for this room calls for heat, this head will open that valve and flow can then go around that circuit. We're now going to fit our ball valves. These are the next part of the manifold assembly. It comes in 2 parts. We've got a 1-inch female connection here. And the first part of the ball valve fitting has a 1-inch male that's going to screw into there. So I'm just going to put that in. Again, we're just going to be hand tight at first and crank down with the spanner after. Now you notice there's a rubber washer in here. That's going to seal this part of the ball valve, so I'm just going to set this aside for now while I just tighten this one up. It's now nice and snug. We're going to put our rubber washer back in here. Connect the second part of the ball valve fitting. Again, hand tight at first, crank down with the spanner after. So you're going to get a bigger set of grips, because this nut is larger than the one on the inside. Top tip, turn the ball valve sideways so it's out your way. Now we're going to want to keep some tension on this fitting that we've already secured into the manifold. So a bit of counter tension. And that's now on there nice and tight. We're now going to do the same with the return side of the manifold. Again, it's in 2 pieces. Set our rubber washer aside for now. Again, I'm going to open our ball valve so it's going to be out of the way later when we tighten this down. And we're simply just going to tighten this up. So the next part of the manifold assembly is the pump and the mixing valve unit. So this is going to be responsible for circulating the water around the manifold assembly. So the blending valve itself can go from 20 degrees all the way up to 55 degrees. A typical system will run, if it's running efficiently, anywhere between 35 and 45, depending on obviously your house's insulation standards and what you can get away with. But the lower you can run this blending valve on, the more money you'll save on your heating bills because it's less work for your boiler to do. You can see they've got a 1-inch male fitting on here, and that simply just connects into the ball valves that we've just installed. What I did forget to show you was the rubber washer on the pump. This seals the union between the pump and the ball valve. Again, just turn your ball valve so they're not in your way so you can get easy access to your fittings. I'm simply just going to carry on tightening this down until we've got a good secure connection. You notice I'll tighten the top a bit, then the bottom a bit. Now I'm going to come back to the top. Do it this way. You're a lot less likely to distort this rubber washer as you're applying even pressure as you're tightening up. So we've now got our hose lock fittings attached to the fill and drain valves on this manifold. The fill and drain valves are integral, they're part of the manifold. Some other manifolds might have them external, ours are integral. We've got these connected on. Before we start filling the system up and getting ready to pressure test, we're going to fit some optional but highly recommended upgrades to the manifold. We're going to fit an automatic air vent to the top, and we're going to fit a pressure gauge to the bottom. So now these are, as standard, the manifold comes with a manual vent valve. Simple half-inch connection, you just undo that and replace like for like. So we're going to start with the top section of the manifold. We're going to undo this. Pop this out. Now the automatic air vent can go in. Fit our pressure gauge. You see the little rubber O-rings, make sure that's set there on there nice and straight. So now we've got the pressure gauge on there hand tight. You can now nip up this nut at the top. We've now got these fitted. Now we're going to use a standard radiator key. We're going to, in a minute, we're going to open this up so that the water can come in through our hose pipe here on the fill side. Before we do, we're going to remove all of our dust shrouds that are on the flow meters. And set them aside for now. I'm going to open all of these up fully. I'm going to tighten all of these down on the return side. And we're going to fill each circuit one by one. So to do that, obviously we're going to open this with the rad key as I said before, and then we're just going to undo this so that you get flow coming in and down and back, and it will eventually drain out along with any air that's trapped in the circuit into the bucket. Now see, we've got flow coming in as indicated by your flow meters. So you've undone the drain off side of the manifold as well with our rad key. We've opened just the first circuit. As you can see, it's the only one that's getting flow. And eventually we'll see some water coming out of the pipe along with any air that's trapped in the system. So what we're going to do now is we're going to fill this circuit, wait till the water comes out of the bucket unimpeded, as if we've just turned the tap on. We don't want to see any burbling, any hissing, don't want to hear any of that. We want just a solid stream of water, and when that happens, we know that this circuit is fully filled, all the air is gone. We can replace our cap, tighten it down, and then open up the next one, and we'll just move along the manifold until all of the circuits are filled and all of the air is purged out. So all of the air bubbles are now starting to disappear. And tighten this down now, and we can move on to the next circuit. So we've got all of our system filled up. We've got rid of the air. We're now going to get ready to do a pressure test. As you can see, I've got a pressure tester down here. I've filled the reservoir with water. I've attached my pressure tester adapter to the drain off point. I've completely closed off the fill side, so we're only able to get anything into the manifold, namely pressure, from this point here. First thing we've got to do is we've got to get air out of the line in the hose. So I'm just going to pump that through now. And lock that off, so now this line's full. I'm going to attach it onto our adapter. This is 3/4 to 1/2 inch, by the way. It's handy to know. And now we're going to reopen this. We're going to introduce the pressure again. We're going to bring it round to anywhere between 4 and 6 bar. We're going to leave it for half an hour. And what we don't want to see is any drops in that pressure. We want it to hold steady for half an hour, and we know that we've now not got any leaks and we've not got any loose connections around the manifold. So I'm just going to open this now. And we can start letting the pressure in. So once we get to 4 bar, we're going to just hold it there. And we're going to lock this off. See you in half an hour. So it's been half an hour. The pressure gauge is holding steady at around 4 bar. You might get maybe a tiny fluctuation from what you put in, as long as it's not dropped drastically in that period of time. I mean, we're probably about 3.9. I'm going to call that 4 bar. We can now disconnect our pressure tester and we're good to go. So with the pipe connected, pipe filled with water, manifold under pressure, that completes the installation of the ProWarm multiple zone water system. For more information about any of our products, both electric and wet underfloor heating, visit ProWarm.com.